Okay, I think we're live again. We had some internet trouble. I cut out. And I believe I'm not sure when it cut out for you guys, but it looks like it cut out before I was actually through all the rules. So let me come back here and do a little preview here. Okay, so now that we're back up and we're running again, and it looks like the connection is okay. Whew, I hope so. Let's go back to our rules. So, assuming we got through rule number 5, let's just go ahead and go over rule number 6 again. So, when we're doing oxidation states and we're doing them for a neutral compound, the sum of our oxidation states need to equal 0. Now, that's for a neutral compound, but we can also do oxidation states for charged species. So, if you're doing oxidation states for elements in a polyatomic ion, then you're going to have an overall charge. Well, in that case, your oxidation states need to equal whatever that overall charge is. Again, we will do examples and I will show you how this works. But we are going to start with neutral species first before we deal with things like polyatomic ions. Okay, so let's go ahead and work some examples here. So starting with carbon monoxide. I am going to use rule number 4. Oxidation state of oxygen is -2. So there is my -2. I am also going to use rule number 6. So this is a neutral compound. The sum of my oxidation states must equal 0. Therefore, the oxidation state of carbon is +2 or 2+. I think I want to switch to the thicker marker here. Okay, so we'll do the same thing. Let's do nitrogen monoxide. Again, I'm going to use the same rules. This has got oxygen in it. It's a covalent compound, so +2. So that means each nitrogen is +1. Okay, so my oxidation state on oxygen is -2. My oxidation state on each nitrogen is 1. So this 2 is a multiplier to nitrogen. Okay, so now we're going to nitrogen dioxide. Again, oxygen, covalent compound, has an oxidation state of -2. This 2 is a multiplier, meaning that I'm going to take that -2 and multiply it by 2. So for the oxidation state for both of those oxygens is going to multiply to give me -4. Again, I'm trying to get to a neutral compound. I need my oxidation states to add to give me 0, which means that nitrogen in this case must be +4. So it's really important that we keep these multipliers in our mind as well. Okay, all right. Now we have N2. This one I put in specifically because it is a little bit tricky. We were using oxygen in all of the other ones, but N2, this is actually rule number 1. So nitrogen in its elemental form forms a diatomic gas, N2, so the oxidation state of this compound is 0. Again, there are a handful of these diatomics. Nitrogen is one of them, oxygen is another one, and like we saw up here, hydrogen and chlorine. So I think the easiest thing is to memorize these handful of few, or talk to your teacher or professor and ask them which ones you should memorize. Okay, let's do, we're going to do more nitrogen compounds, but in this row at least, let's do one more nitrogen compound. So this is an ionic compound. So what we've got here is we actually have 2 monoatomic ions. So we have lithium and we have nitrogen. Now lithium, when it is an ion, has a charge of +1. So in this case, its oxidation state is its charge. There are 3 lithium, so that gives us an overall oxidation of +3, which means that nitrogen must be -3. Again, we're looking at a neutral compound here. You could have done this the other way. You could have started with nitrogen and said nitrogen. When nitrogen is an ion, it has a charge of -3, therefore that is its oxidation state, and then use that to find the lithium. But they both work together and they both are following all of the rules. Okay, let's move on to some more. Let's make sure there are no more questions. Now we have nickel and oxygen coming together. So we're dealing with a transition metal here, but that's fine. We don't, this is not a naming situation where we need Roman numerals. So write note